Okay, last video for chapter 3. We're going to now talk about standard deviation. So, your 5-number summary, it's not actually the most common numerical description of a distribution. That would belong to, and I think I said this in the last video, that's going to belong to the mean to measure the center. And if you're using the mean to measure the center, then you're going to be talking about the standard deviation to measure the spread. So, let's take a look. So the standard deviation measures your spread by looking at how far are your observations from their mean. So it's a distance. Standard deviation is a distance from the mean of the data. Okay, so let's kind of take a look at how we would find this. It's a long process. We generally do not do it by hand, and I shouldn't even say generally. I should say we'll never do it by hand. However, let's take a look at how it would be done. So to find the standard deviation, the first thing that we should do is find the mean, okay? You can't find the distance from the mean unless you actually know what the mean is, okay? After that, you're going to calculate each deviation, so each distance. So it's your observation minus the mean, okay? So if you were talking about the number of pets being 1, if the mean of the number of pets in the class, or of the group of 9 children was 5, then the deviation from the first observation would be -4, where the deviation from the observation of 8 pets would be 3. You run into a little bit of an issue here. Distance can't be negative, okay? So this in itself doesn't really make sense to us. And so there is a little bit that we need to do in order to find. Also, we can't just have different sets of numbers. We need a standard deviation. We need one number to express your spread of your data, okay? So kind of 2 things that we have to take care of is what do we do about these negatives? And finally, how do we express it as one number? Okay. So after we find our deviations, the way that we can take care of the whole idea of our negatives is by squaring them. So here's our deviations right here. We started to show them on the last page, the first observation and that 8th one. Okay. And then we square them. Okay, this has to do with not having negatives. If it's a distance, negative wouldn't make sense here. So we square them to get rid of them. But we still run into the issue that well, we don't have them all together. We need to understand this as a group, as a whole, okay? So what we'll do next is we'll calculate the sum of the square deviations, okay? So we're going to put them all together in one sum, and then we're going to divide this by n-1. This is an idea I'll talk to you quickly about in class. This is going to give you a number called the variance, okay? Still not the standard deviation, okay? In order to get the standard deviation, now you're going to have to almost go backwards, okay? So it's like a little bit of an error here. So to calculate the square root of the variance, that's what's going to get you your standard deviation. So the average square deviation here is going to be 6.5. That's your variance. Your standard deviation is the square root of your variance. So square root of 6.5 is going to give me a standard deviation of 2.55. Okay. So the standard deviation measures the average distance of the observations from their mean. It is calculated by finding an average of the square distances and then taking the square root. This average square distance is called the variance. So you can see here's what we did in a chart, but this is just as one whole kind of formula, so to speak, on how we can express what all those columns in the chart did. Okay. The standard deviation, however, is going to be the square root of all of that. You'll often see them just put this over n-1 instead of doing that. In fact, I think that's what your reference guide will say. but we'll discuss that in class, and we'll mark up our reference guide in class. Okay, so let's go ahead and find the mean. So what we're going to do is we're going to add them all together. Okay, 76, 84 over 1, 2, 3, 4, 5, which is going to give me a mean of 75. Okay, now we're going to start to calculate the variance and the standard deviation. Okay, so you can do this as one. I'm going to do it separately. So here's where we're going to find the variance. So the variance, how to find your standard deviation is notated as follows. So your variance would be your standard deviation squared, and so this is how you notate your variance. Okay, so you're going to take each of your observations, subtract it from your mean, square it, and keep adding them to every next one. So 72 minus the 75 average squared plus the same thing plus your last the fourth observation plus the last observation minus your mean squared, and you're going to put all of that over n minus 1. So that would be 5 observations minus 1. Okay, so the whole top is going to get you 156 over 4 to give you a variance of 39 inches. Okay, that wouldn't make sense if you think about standard deviation being a spread or a spread of your numbers. That's entirely too high. That wouldn't make any sense to describe this distribution. So that there would be your dead giveaway that your standard deviation is going to be the square root of your variance. Okay, and so here my spread would be 6.24 inches. Okay, something very important to understand is how do you describe or interpret your standard deviation. Okay, your standard deviation is how your variables typically vary from the mean. Okay. So in terms of how you would interpret this one in context, we would want to say the players' heights typically vary by about 6.24 inches from the mean height of 75 inches. Okay. So now just as far as, let's quickly talk about if we have to choose, when we are choosing our measures of center and spread, it's very important to keep things together, okay? So now if you're talking about the mean, make sure that you're talking about the spread in terms of the standard deviation. If you choose to speak about the median as far as your spread, as far as your center, then you should talk about the interquartile range to discuss your spread. Okay, so the median and IQR are usually better than the mean to describe skewed data. Okay, remember that the skewed data distribution is going to pull the mean in one direction. Okay, not giving it its best best value for its center. You'll use the mean and standard deviation for distributions that are roughly symmetric. They don't have to be perfectly symmetric, so I use the word reasonably, okay? And that don't have outliers, although that's flexible, okay? Numerical summaries do not fully describe the shape of a distribution. Always plot your data. So just because you have your five number so that you can come up with a box plot, but that's not necessarily going to tell you the shape of your distribution. I'm going to show you more of that in class. And that last example I want to also go through with you in class, because I want to talk about how you should be setting up your stats problems from here on out.